we get started today, are there any questions over the homework? Questions over any of the homework assignments? Okay. What we're looking at today is more solving these rational equations, So one of the big things, especially for today, we're going to need to make sure that we're checking our solutions and making sure that they're not extraneous solutions. Because an extraneous solution is a solution that we do get from solving the problem, from the solving process or solving steps that we do to solve it, but it does not work in the original connotation. And this comes up in a lot of different areas. Extraneous solutions do show up in a lot of mathematics when we try to solve problems. One of the big ones that does come up is if we talk about parabolas and arcs in word problems. We can sometimes get solutions that don't work, or if using Pythagorean's theorem, square root of 144 is plus or minus 12. But if we're talking about sides of a triangle, we can't have a negative distance, a negative length. Those are extraneous solutions. They are solutions that mathematically do work, but don't work in our original problem. So if we look at this here, our extraneous solutions are going to be whatever value of x is going to make the denominator be 0. Now we do have three denominators. We have x plus 1, 2x, and 2x. So what we can do is set each one of them equal to 0, and if there's one repeated, we don't have to do it twice, because it's just going to be the same answer. Well, 2 times x equals 0, well, that's just, realistically, x is going to be 0. Now, there's two ways we could have gone about that. One is dividing both sides by 2 and solving it, or our zero product property. Zero product property states if any two things multiplied together equal 0, one of them must be 0. And 2 times x, well, we can't make 2 0, so the only thing is x has to be 0. So we know one of our restrictions is that x cannot be 0. If x shows up as 0 as one of our solutions, we throw it out. It's an extraneous solution. The other one, minus 1 from both sides. So one of the other values of x that will make the denominator 0 is negative 1. So our two restrictions for this problem are 0 and negative 1. So if one of the solutions that we get for this problem is 0 or negative 1, we can throw it out. Now if both solutions, or all the solutions were 0 and negative 1, that's the only thing we got, then it is no solution. There is nothing that works. Okay, now we can start solving this here. Now the first main step is to find the least common denominator, or really figure out what we need to multiply each of these rational expressions by to get the denominator simplify. Well, if we look at the first one, we will need to multiply this by x plus 1. To get the denominator to simplify, it needs to be multiplied by x plus 1. But if I do it to one of them, I have to do it to the rest. And if we look at this here, this x plus 1 and this x plus 1 will cancel out, yes? What would we need to do for the middle term? 2x, yes? And if we do it to 1, we've got to do it to all of them, yes? And well, the middle 2x and 2x will cancel. What about the last one? What's 2x and 2x will cancel, yes? And this might be a good way to go about it. Do it one at a time. Apply it to all three, simplify. If there's still fractions left, keep going from there. And again, just as a reminder, only 1 will cancel out with 1. If we had 2, we will need 2. Questions on this here? So let's see what's left. In the first one, we have 3x in the numerator, and it's being multiplied by 2x minus 5 times, well, 2x, 2x, so the only thing that was left was x plus 1 equals 3 times x plus 1. Any questions on how we got to this here? Any questions over any of this so far? Now we do need to distribute and solve for the value of x. So here, 3x times 2x, 3 times 2 is 6. X times x is x squared. Distribute the negative 5. Negative 5 times x is negative 5x. Negative 5 times 1 is negative 5. Here we'll distribute the 3. 3 times x is 3x. 3 times 1 is going to be plus 3. Do we have any like terms on either side of the equal sign? Not on the sides, but there are like terms on both sides. Now, since it is a quadratic, we have a degree greater than 1. We have an x squared term. We need to get this equal to 0. So the first thing we can do is subtract 3x from both sides, which will tell us that 6x squared minus 8x minus 5 is equal to 3. Then we will need to subtract 3 from both sides, which gives us 6x squared minus 8x minus 8 is equal to 0. And the order in which we do that really doesn't matter. I could have subtracted the 3 first instead of the 3x first. Either one works. We just need to make sure that it is equal to 0. Questions on this so far? Is there a greatest common factor between these three terms? 2. And since it's just a number, we're going to divide it out of the entire thing, the entire quadratic. Because we're going to simplify it. 6x squared divided by 2 is 3x squared. Negative 8x divided by 2 is negative 4x. And negative 8 divided by 2 is negative 4. Is equal to 0. Now at this point here, we can graph it, quadratic formula, factor it. We can do any of these here. I would shy away from graphing it because most likely it may give us one solution, one nice whole number, but it's probably not going to give us 2. And the reason I say that is because since there's a value in front of a and value in front of x squared, most likely one of our 2 solutions will be a fraction. Now what we can do instead is we can go on and try to factor this. 2 sets of parentheses with 3 spaces. Since the 4 is negative, our signs are opposite. One's going to be positive, one is going to be negative. We can start with 3x squared because the factors of x squared are going to be x and x. And the factors of 3 are 3 and 1. Now the factors of 4, 1 and 4, or 2 and 2. Which one do we want to try first? 2 and 2. Now it will be good to check this. 3x times negative 2 is going to be negative 6x. 2 times x is going to be plus 2x. And negative 6x plus 2x is indeed negative 4x, which is quite convenient. So these here are our solutions. Almost finished. Since we have 2 things multiplied together to equal 0, one of them must be 0. So either 3x plus 2 is equal to 0 or x minus 2 is equal to 0. So the first thing we can do is subtract 2 from both sides, leaving us with 3x equal to negative 2. And last but not least, we can divide both sides by 3. Scroll up just a little bit. Telling us x is equal to negative 2/3. For our other one, we would add 2 to both sides, telling us x is equal to 2. Now, are either one of these solutions are restrictions? No. So that means both of these will work. And if we plug them back in and checked them, we would see, yes, both of these do work. So these here are our two solutions. Any questions over any of this here? We're ready for the next one. Now, this one here is a little bit different. Because if we look at this one, the denominator of our middle rational expression, x squared minus 1, is not in simplest form. It might be very tempting to multiply everything by x plus 1 and x squared minus 1, but it's going to make the problem harder than it needs to be. Whenever we solve any of these here, any of these rational equations, we want to make sure all the denominators are completely factored. Now, up to this point, we haven't had to worry about it, because every one we've done so far has already been in simplest form. They didn't have any factors, greatest common factors, nothing we had to do to them. This one's the first exception, because we have x squared minus 1. And x squared minus 1 will factor to what? Yes, x minus 1 and x plus 1. It is the difference of perfect squares. So we have x minus 1 and x plus 1. So if we had gone through and just multiplied everything by x plus 1 and x squared minus 1, we would have had added an extra x plus 1 as a factor through everything. Which means if we were going to supposed to end up with a quadratic, that means x squared is our variable with the biggest power, we would have not have ended up with that. We would have ended up with x cubed. So instead of trying to solve a quadratic, we would solve a cubic. Or instead of solving a cubic, we would have solved a quartic. We increase it by 1. But what that also does is give us another solution. And that additional solution that we get will always be in an extraneous solution. Anything we go above the least common denominator will be extraneous solutions. Now, talking about extraneous solutions and least common denominator, looking at the denominators, we have two. One of them is x plus 1. The other is x minus 1. Those are our two things that can be 0. And we can solve them. So for x plus 1, we would subtract 1 from both sides, telling us x cannot be negative 1. For the x minus 1, we can add 1 to both sides, telling us it cannot be 1. So this here is telling us that we cannot have a value of negative 1 or 1. If we have one of those two values, it will be an extraneous solution and will not work. So, what do we need to multiply each of these terms by? So we can start off there. We can multiply each one of them by x plus 1. This single term. Well, here the x plus 1 and x plus 1 would cancel, yes? In the middle one, the x plus 1 and x plus 1 would cancel, yes? 3 doesn't have a denominator, so it's just going to stay the same. Are all the denominators simplified? No. What else do we need? X minus 1, because if we multiply the middle one by x minus 1, they will cancel. If we do it to 1, we have to do it to the rest. Now are all the denominators simplified? Yes. Now again, this numerator 4x plus 1 is considered a term. Okay. So if we see what we have left, the first one we have 4x plus 1 times what? X minus 1 is equal to 12 times nothing. Everything we multiplied it by simplified out, plus 3 times, well, wait a minute. What are we multiplying the 3 by? X plus 1 and x minus 1. Where did we get the x plus 1 and x minus 1 from? X squared minus 1, yes? So what should these two things multiply back together to be? We could have written it out. There's nothing wrong with doing x plus 1, x minus 1. Because they will multiply back together to be x squared minus 1. If it works out that one of the terms, what they're being multiplied by, we got them from factoring, you can put them back together. There's nothing wrong with that. There's also nothing wrong with writing x plus 1 times x minus 1 next to the 3, because when we multiply it, we'd get x squared minus x plus x minus 1, which is x squared minus 1. We would get back there. But if we do notice that the two factors we're multiplying together came from something we factored already in the problem, might as well just put it back together. Now we do need to distribute. So on the left side, we're going to multiply through. 4x times x is 4x squared. 4x times negative 1 is negative 4x. Then we do 1 times x is going to be plus x, and 1 times negative 1 is negative 1. Now we don't do anything to the 12 because there's nothing being multiplied by it, so we just rewrite it. Now the 3 we will need to distribute. 3 times x squared is going to be 3x squared. 3 times negative 1 is negative 3. Questions on this so far? Now there are some like terms on both sides we can simplify. Negative 4x plus x is going to be negative 3x. On the right-hand side, 12 minus 3 is going to be plus 9. Now at this point here, we do need to get this equal to 0. So it doesn't matter which one we do first. We can subtract the 3x squared from both sides or the 9. I'm going to do 3x squared first. The 4x squared minus 3x squared is going to be x squared. Minus 3x minus 1 is equal to 9. Now, I could have subtracted the 4x squared, but I don't want to move everything from the left to the right. Because if we're going from left to right, I'm going to need to move 3 things. I'm going to have to move the x squared term, the x, and the constant. I would rather go from the right to the left because I'm only having to move 2. Y'all see that? Okay. And last but not least, with our moving everything to the same side, we'll subtract 9, which will tell us that we have x squared minus 3x minus 10 is equal to 0. Now at this point here, we can graph this if we want to solve it. Because A, the number in front of x squared is 1. So most likely, if we do have rational solutions, they're going to be whole numbers. So we can grab the graphing calculator, take both of these out, and say x squared minus, try to get it right, 3x, x minus 10. And hit graph. We see that the graph does cross at 2 places. So we go second table. Now we see 2 places because when we graph it, we're looking for what value of x will make the y be 0. And there's 2 spots, negative 2 and 5. And those would be our solutions if we factored it. it had been x and x plus and minus 2 and 5. And when we solve this here, x plus 2 is equal to 0. If I solve this here, I would subtract 2. Tell me x is equal to negative 2, which we did find by graphing. For the x minus 5 is equal to 0, we would add 5, telling us x is equal to 5. And that's it. Or either one of these are restrictions. No. But that's it. Any questions on any of this here? Now, on the test, if it does say to check your solutions, it'd be a good idea to check them. Because I do count points, especially on the test for checking your solutions, especially Algebra 2's test. And really, so negative 2 and 5. So we say 4 times negative 2 plus 1 over negative 2 plus 1. 12 over negative 2 squared minus 1 plus 3. The first thing I would do is plug the value in. I'd plug negative 2 in. I'd grab the calculator and I would not do the whole thing. I'd just do one side at a time. So 4 times negative 2 plus 1 over negative 2 plus 1. We get a value of 7. So when simplified, the left-hand side is 7. Okay? Grab the calculator again and say 12 over negative 2 squared minus 1 plus 3. So we just type it in exactly how it is with that value plugged in for x. Tells us the other side is 7. Is 7 equal to 7? You can put a check, say yes, we checked it, it does work. Then we can do the exact same thing for 5. Say 4 times 5 plus 1 over 5 plus 1 is equal to 12 over 5 squared minus 1 plus 3. And again, the calculator, we can say 4 times 5 plus 1 over 5 plus 1. We get 7 halves. Then we need 12 over 5 squared minus 1 plus 3. There's also 7 halves. So we have 7 halves is equal to 7 halves. It works. And that's all you need to do to get the points for checking your solutions. Pretty easy. Those should be some of the easiest points you get on the test. Yeah. Just making sure to do them. Any questions on these so far? So let's look at this one here. So our denominators that we have for this one are x minus 3, x plus 3, and x squared minus 9. Are all three of these in simplest form? Can we factor x squared minus 9? Because two terms, so and x squared, well, x squared is a perfect square, it's x and x. 9 is a perfect square, it is. 3 and 3, so this would factor 2, x minus 3 and x plus 3. And yes, that was supposed to be a 3. So we'll look at restrictions first, and then we'll deal with the least common denominator. Now, at all three denominators, there's really only two that are unique. We have the x minus 3 and the x plus 3. And probably at this point, you could tell me what value of x will make x minus 3 be 0. And it is. Well, we would have negative 3 for one and positive 3 for the other. Because for this one here, we would add 3 to both sides, telling us x is equal to 3, which is one of our solutions because we can't have it. And the other, we would subtract 3, telling us x is equal to negative 3, which would be our other one. Because if we get a solution of 3 or negative 3, those would be our restrictions because we cannot have it. If we have one of those, it'll make the denominator be 0. What is one thing we know we'll need to multiply each of these expressions by? X minus 3. We'll need an x minus 3. As for our first rational expression, the x minus 3 and x minus 3 would cancel. In the middle one, the x minus 3 and x minus 3 would. And in the last one, the x minus 3 will not cancel because we have an x plus 3. Because if we multiply through with one x minus 3, it'll only cancel out one x minus 3 in each of the rational expressions. If there's 2 and 1, we need 2. What else do we need? We also need an x plus 3. Now in our first rational expression, the denominator is gone. It won't simplify with anything. The middle one, we will have 1x plus 3 on top and bottom. That will cancel. And in the last one, the x plus 3 and x plus 3 will cancel out. Now let's see what that leaves us with. So we have 6 times x plus 3 is equal to 8x squared times, well, everything we multiplied it by simplified out with the denominator. So it's just 8x squared minus 4x times x minus 3. Now at this point here, we can distribute some, so we'll multiply through the 6. 6 times x is 6x. 6 times 3 is going to be plus 18 is equal to 8x squared. Distribute the negative 4x. Negative 4x times x is going to be negative 4x squared. Negative 4x times negative 3 is going to be plus 12x. Now we do have some like terms on the right-hand side. 6x plus 18. 8x squared minus 4x squared is going to be 4x squared plus 12x. Since we still have this x squared term, we're going to need to get everything on the same side. So the first thing we can do is subtract 6x from both sides, which will tell us that 18 is equal to 4x squared plus 6x. Last but not least, in getting everything on the same side, we would subtract 18 from both sides, telling us that 0 is equal to 4x squared plus 6x minus 18. Is there a greatest common factor between these three terms? Almost. A little bit smaller than 4. 2. 0 is equal to 2x squared plus 3x minus 9. Now at this point here, we could try to go about graphing it, but most likely graphing will only give us one rational solution, if any. So we can factor this. 2 sets of parentheses with 3 spaces. Since the 9's negative, our signs are opposite. One's going to be positive, one's going to be negative. Our factors of 2x squared, we have x and x, then we'll also have 2 and 1. Most likely I'm going to end up having to switch the signs, but that's fine. Now the factors of 9 are 1 and 9 or 3 and 3. I'm going to try 3 and 3 first. And if we check this here, 2x times negative 3 is negative 6x. 3 times x is going to be plus 3x. And negative 6x plus 3x is negative 3x. Is that the middle term we wanted? No. Is it the correct number? Yes, it's just the wrong sign. So all we need to do is flip the signs, which will change it to 6x minus 3x, giving us a positive 3x. Questions on how we got to this here? We good with this here so far? Now the last thing we need to do is solve. Since we have two things multiplied together to equal 0, one of them must be 0. So either 2x minus 3 is 0 or x plus 3 is 0. Here we can add 3 to both sides, telling us 2x is equal to 3. Divide both sides by 2, telling us x is 3/2. Then for the other one, we would subtract 3 from both sides, telling us x is equal to negative 3. Is one of these two solutions, well, I'll hold on a second, let you all finish writing. Do both of these solutions work? Which one doesn't? That's one of our extraneous solutions, yes? One of the ones we listed at the top of the page, so it doesn't work. The 3/2 does. Because if we went back to the top, so 3/2, if we tried negative 3, 6 over negative 3 minus 3, 8 times negative 3 squared over negative 3 squared minus 9, 4 times negative 3 over negative 3 plus 3. Well, we don't even have to look at almost all of these, because the left side, 6, be over negative 6. Here we have 8 times 9. Negative 3 squared is 9, negative 12. Here, negative 3 plus 3 is 0. I don't have to go further than that because that doesn't exist. Negative 12 over 0 doesn't exist. Here, we have 9 minus 9, which is 0. This one doesn't work. We cannot have it as a solution. It does not work in the original problem. It is a solution that we get from solving, but it's an extraneous solution. Yeah. It's just a part of the problem-solving method, and with the multiplication in squares arises the issue because of the fact that a square of a negative number is positive and the square of a positive number is positive. We get that offset where, especially here and here, kind of that doesn't take back into account. So negative 3 doesn't work. 3/2 is the only one that does. Now we'll